Thanks for having me. Obviously, the sponsored keynote, so there's a bit of commercial in here. I'm going to try to keep it somewhat technical compared to last year, but let's see how it goes. So basically, intro slide, right? Jeremy Clarkson, pretty famous for saying stupid shit and then getting owned by it. So I'm going to try to do the same. So in the room today, we have a bunch of technical people, we have a bunch of commercial people, and also marketing people. I have myself, so I usually do spreadsheets and PowerPoints. I tell myself that I'm somewhat technical. Tobias and Lasse usually disagrees with that statement, but they are also in the room. Since this is technical, if you have some questions afterwards to what I'm going to say here, I'm going to point you at one of those two guys. The reason why I'm here is because they'd rather die than be up here. So here we go. Anyways, I have to keep commercial and sales a bit happy to make sure that they keep paying for these things. So today I'm representing ScanNet. ScanNet is part of the larger Team Blue group, which is across all of Europe. ScanNet is business to business. CureNet is reseller, so business to reseller. Dan Domain is direct to customer, and Simply.com is if you're cautious about spending your money, I'd say. But as for products, managed Kubernetes, private cloud, storage as a service, GPU as a service, database as a service. We just entered early access for the OpenSearch as a service, and then we have many other things as a service. If you have any questions regarding these things, come by the booth. With that said, I think marketing is happy. So this whole thing is the story about us like rethinking our CSI infrastructure for the fifth time or whatever. Our third time, because what we had just didn't really work for us. So this is we try to be on the infrastructure level, so there's going to be network drawings and all that stuff. There's going to be no YAML files, so that's a bit strange for you maybe. But to set the scene, we have five data centers in Denmark. 3 of them, we treat them as production data centers, which is where we keep the production data. And all of them are connected by a ring of 800 gig. And that sort of sets the scene for why we're doing a multi-site CSI. So why do we need it? Basically, so regular Kubernetes, right? Some of you do stateful stuff inside of your Kubernetes clusters. That needs somewhere to put the storage, so we need something for that. Then we have certain customers that are doing multi-site Kubernetes. Those certain customers also do stateful stuff inside their clusters, which means they need to have access to the same storage across the data centers, right? So we need something that spans all of it. And then we do have some customers that are doing disaster recovery, or where we sell them disaster recovery as a service. What we've seen is that not all applications are written equally. Certainly not all of them are site-aware. Most are not. And not all are able to be deployed from scratch with GitOps. You know who you are. So if we have a cluster and it should be protected and should be failover to another side, it still needs to boot up there, and then it certainly needs to have access to the storage that it had access to before, right? And then more importantly, everything we do is by default sort of unmanaged on the application side. So we need to make something that has a change nothing failover, which means that we enable the customers to click the button themselves and do failover. And then, given that fact, we should not be involved in that process, so we can change absolutely nothing doing that failover, which, especially in networking, can be a bit of a challenge. So technology choices, right? So these are some of the things we've tried over the course of the years. So Longhorn, I'm a big fan of that. The only issue with that is that it's native to the cluster, right? So it's kind of hard when we want something that is external to the cluster, so we can do cluster lifecycling without touching all the storage components. So that pretty much was disqualified there. We wanted something that was site-aware. That sort of killed the NetApp stuff. We needed some NVMEs, or we needed the ability to have NVMEs in this, because you all know this. Very fast storage and very fast CPUs fix a lot of coding issues and a lot of coding performance, right? So let's try to not have focus on optimizing code, and let's just make it work instead. And then backend should be dynamically expandable, right? So ability to add storage wherever we wanted to do it, right? At one disk at a time or one node at a time, who cares? And without talking to a sales guy. So also disqualified some of them. Should have a rich CSI feature set. So that killed my baby, which is PowerFlex. I'm a huge fanboy of that. but they do not have a rich feature set. So it's something like, what is it? Read-write mini, for instance, is not a thing that in their world. Then should have a long track of keeping up with Kubernetes, which again, Dell is. If Dell is in the room, you should improve. And then should be software first. So if you notice, there's like a trend of all the way to the right. Ceph seems to check all the marks right, which is funnily enough why I'm doing a session about it. So Ceph, we've been running Ceph for, I want to say 5 years, maybe more. Well, I think we have like in the double-digit petabytes of Ceph running. So for this thing, very quickly, 6 servers, 2 on each side. They have X amount of NVMEs. I've written 5 here. That's a mistake. They have 3. They have some CPUs, they have some memory, and they have some NICs. Then networking between sites, it's all layer 3, so no layer 2. That's been stretched because if you have layer 2, you have a single logical site. Tell that to your networking guys. It's not separate sites if it's layer 2. Then on the software side, we're doing Ceph Reef 18.2, and yes, I know Squid is out, but we're also paying a company called k8s for the support. So in the case that we cannot fix things ourselves, we have someone to call, and in their words, Squid is not ready for production yet. So that's why we went with Reef. And to be fair, this is like 6 months ago, right? Then we have a 3-way mirror layout, so all the data gets mirrored across the sites. So 1 in each, back to the 3 data centers part. And then all the replicas are site aware, so we make sure that a copy of a block does not end up in the same site as the other copy, right? So that's basically it. Good, easy part over. I'd say we went into this with a lot of hope. This should work, right? And a lot of confidence because we know this thing. We've done our research, and then back to Jeremy Clarkson, a shitload of ignorance, because it was a bit harder than we anticipated, right? There was quite a few moments where we think, okay, we might have misjudged this thing. So, but basically, this should work. How hard can it be, right? So the remaining challenges: networking and permissions. Good. Okay. So issues with networking. So each storage subnet is different, layer 3 on the different sites. Back to we do not span layer 2, right? So we need to be able to reach all the nodes in each site, which is fairly easy if you only have a single NIC, which we don't. Each Kubernetes worker has to be multi-home, so 1 NIC for the production traffic, which is your applications and all that stuff, and then 1 NIC to serving I/O to the storage, right? So that means only one can have the gateway, and the other one can't. So we need to fix that in some way, and then we can't change any IPs doing any sort of failover. Because if we do that, then we have to be engaged, or we have to tell the customers to do something. If we tell them to do something that's not the application, they'll more than likely fail. So a network diagram. I don't know how good this is on the screen, but more or less, green means production cluster, gray means failover cluster. So the bottom green one says k8s workers. I don't think you can see that, but it does. Default gateway is northbound, and then we have static routes going southbound, but we also had the issues that we need to figure out a way of traffic getting back to these things, which means we introduced this, and it says global self-announce range here in the bottom, but it's basically us implementing FRR, which is a routing engine in Linux, on each k8s worker, so they announce a /32 to the network. That's globally unique. And then using that, they can reach the storage networks in all different sites. So it's basically us peering our Kubernetes workers by default with a router somewhere using FRR and BGP. And then the network sort of knows how to get to these things, and it knows how to get the other way around without disturbing the customers' front-end networks. So this sounds pretty easy. I think, Lasse, if you're in the room, you spent the better part of a month. Yeah, he's down there. He spent the better part of a month trying to fix this and standardize this and lure out all the bugs and all that stuff. So networking fixed. Now, permissions. Whoever builds Ceph needs to rethink their life. I mean, the permissions are broken by default. If you're somewhat into traditional storage, you know that you as a storage admin, you assign permissions to like all the clients. Oh, 5 minutes, I'm screwed. You assign permissions to all the clients and say, this is what you can see. In Ceph, they chose this approach of the client must be right? So whatever the client says it needs, it should get. Which by default means that all clients can just mount all volumes, which is brilliant. Anyway, so we need to fix that. So on the block side, it's pretty easy. Just a second. So pretty easy. Create a Rados namespace, create a key, assign to the namespace, assign the key to Ceph CSI, and for the cluster, you're done. Pretty easy. Good. So on the other hand, Cephfs or Ceph file. So yeah, you have this concept of file systems, and again, Tobias is also in the back room. Don't call me out on anything I say now, but if you have questions, go ask him. Basically, you have this concept of either doing a single file system or multiple file systems. Multiple file systems in a large-scale environment is the right thing to do, or is the better thing to do, because it's easier for tenancy. We could not do that due to that would mean that we needed more pools. More pools means more placement groups, and there's a certain amount of placement groups that you should only have per OSD, which, depending on what you think, is between 100 and 200, without going into what that means. And that is like scale that to a few hundred Kubernetes clusters, and this thing gets really, really hard to maintain over time. So we chose to have a single file system. That also meant we have to go with a shared file system. And you had to use sub-volume groups. And when doing that, you really need to get used to stuff like, we think it's like this, or try this, or do whatever. When you ask either the support from k8s, or if you go to the Ceph Slack channel, or in any sort of community list or mailing list, right? So because this is not documented stuff. This is best effort. It works really well when you figure it out, but it certainly isn't documented. And then these permissions needs to be set on both a dedicated folder for all the volumes, but which is easy because then it's like hierarchical. But there's also a shared folder on the top level of the file system that it has to have access to, where all the clusters need to have access. And that's basically permissions mapped to a tag, which is mapped to a key. And it's like, it creates these, you can't probably see it, but these permission sets here in the bottom. That took quite a while. I think we gave up nearly once or twice trying to figure this thing out. But it works now, so if you ever need to do this in a hosting environment or whatever, you ask Tobias about it, or Lasse for that matter. But anyways, figured that out, worked, we're happy. Performance-wise, we did some quick performance tests, some hero numbers here. You can't see that either on the graphs, so good job. But anyways, classic 4K test, right? QDAF 128. So a single part doing this, 65,000 IO a second. The latency is on the left, so that's on the bottom. It's around 0.1 of a millisecond, which is fairly decent. 2 minutes, okay, I'm gonna make this. We did test 2, just another part, so nearly actually doubled. And then did the next one, and then added only 20,000 IO a second. But I think we also this test wasn't that thorough, so we could have probably designed it better. But what we see is that basically this thing scales pretty well. And we're only doing 6 nodes, and we're only doing 3 disks in each, right? So pretty happy about it, and especially with the latency, which is usually the most important thing here. Hey, I'm gonna make it. We have a booth out there. I don't know if you've seen it. We have a Kubernetes challenge. So basically, it's a broken cluster that Lasse has made. There's either 3 or 5. I don't know. There's 3 things that are broken in the cluster. If you can fix it, you'll get on the leaderboard. If you're the quickest one, you can win a oversized chocolate bar. If you just participate, even though you fail or whatever you do, we just want your email so we can spam you. You can win a 5090, right? And I think the raffle is tomorrow. Yeah, tomorrow. I think you have to be present as well, just to keep you here. But basically, we have a 5090. So come by, have a talk, try it out. We learned from last year, so now we have 4 laptops instead of 1. and we made it a bit easier, right? So thank you guys. I think that's it for me. Thank you.